Hello, everyone, and welcome to Derivatives. We are going to study something called linearization today. The good news is you actually already know how to do this. So go ahead and do this problem on your own, and go ahead, pause the video, you can do it, and then come back and jump to the answer or watch it done if you don't get it right. So it says find the equation of the line. So right away, I'm going to go down to my answer. I know I'm looking for this. What two things do we need to find the equation of a line? We need a point. So x1, y1 is going to go right there. And we need the slope. Slope in calculus is derivative. So we're going to do y prime, but I'm going to change it to f prime at that x1. Okay, so they gave me the x value. It's 0. How do you find the y value? You use the y equation. So f of 0 is the square root of 1 plus 0, which is 1. So I'm halfway there already. The point is 0, 1. Now I just need to know the slope at 1. So I do my derivative. You can't do the derivative with a square root, so first thing I'm going to do is change this to 1 plus x to the 1/2. And the derivative is 1/2, 1 plus x to the negative 1/2. You can simplify it if you want to. It would look like this. And what we need is the derivative for our equation of our tangent line at 0. F prime of 0 is equal to 1 over 2 times the square root of 1 plus 0, which is just 1/2. So there's our answer. But the question is, what does it mean? Hopefully you already know, but I'm just going to go through it one more time. This is a square root function. It's written a little backwards for us. Since I know we're all creatures of habit, I'm going to switch to x plus 1, which means it's been moved to the left one. So right there. So it goes 0, 0, 1, 1, 4, 2, not really 4, 2, 3, 2. I've moved it over. That's my fake 0, 0. And what we found is the equation of the line tangent to the curve at 0. So right here at 0, there is a tangent line. That means it just barely touches it and keeps going. And does it make sense that that line would be 1/2 x, the minus 0 doesn't matter, plus 1? Definitely. It definitely crosses at 1. And it definitely looks like it has a slope of 1/2. So this topic today is exactly this, but they gave it a name. The name is linearization. So the reason they call it that is because if you look at a graph really closely, so let's say you've got a window that looks like this, and you have a nice curve. But let's say you made your window smaller. Let's say you just looked at this much of it. It pretty much looks like a line, right? Even a curvy spot, if you take a small enough window, it looks like a line. So this is a little bit of an archaic concept, except it's definitely going to be something you need to know, but just nobody actually uses it this way anymore. Meaning, back in the day, if you had to figure out something complicated, like the square root of 1.89, you couldn't just pull out a calculator and type that in. You had to extrapolate based on numbers that you knew. Well, if you really needed to know something a little bit more exact, then believe it or not, they would say, you know what? I'm going to find the linearization of the square root curve at that point. And then I can just plug my number, my 1.89, into the equation of this line. Going back to our example, if you had a choice between plugging a number into f of x or into the line, you're definitely going to want to plug something into the line. It's just easier. So how long is the line correct? Well, look at this little section. For this little section, it's correct really, really close to 0. If you tried to plug in the number 3, you're not going to get something that's even close. But let's say you did the linearization at that point. How long is that point correct? Well, they're practically on top of each other for a long time. So I realize I've kind of made a long explanation of that. So I did try and write it all down. Today we are giving this a new name, linearization. And pretty much all this paragraph is what I just said. So any normal book is going to give you this formal definition. If y is equal to f of x is differentiable at a, then the linearization is f of a plus f prime of a times x minus a. Wow, they made that sound awesome and important. Watch this. You're going to be so happy about this. This is the easiest thing ever. You guys all know this, right? Y is equal to m times x minus x1 plus y1. This is how you have done the equation of the tangent line and equations of lines for a long time. So think about it. If I have a function y is equal to f of x, then the point a, comma f of a is definitely on that line. I mean, on that curve, whatever it is. And the slope of the tangent line would be f prime at whatever the a value is. So they just took this equation and they plugged it in. So now they made it y is equal to f prime of a times x minus a plus f of a. Then they used the commutative property to switch it around. So they're going to put this first, f of a plus f prime of a times x minus a, and then they gave it a new name, linearization. They switched the y, which is how we did it, right? We just called it y is equal to, instead they're saying this is the linearization. This is awesome. This means you have literally already learned this topic. Despite the new fancy notation, this is just the equation of the tangent line. So find the linearization, fancy code for find the equation of the tangent line. So we need two things to write the equation of the line. We need the point. So when I plug in a 2, you can try this on your own and just come back if you want to. 2 minus 8 plus 3, so it's just 3. And then the slope is going to be 3x squared minus 4x. The slope at 2 is going to be 2 squares, 4 times 3 is 12, minus 8 is equal to 4. So my linearization, so instead of calling it y, I'm going to call it linearization, is 4 times x minus 2 plus 3. No, you do not have to change the order of it. You can still leave it like that. In fact, I'm just going to multiply it out. 4x minus 8 plus 3, 4x minus 5. So I want to take a minute and show you how linearization looks on the graph, so you can see pretty much how awesome it is. So I've already put the two equations into my y is equal to, and I'm going to go ahead and I hit graph. So as you can see, our line is definitely tangent at the point 2. And for a while, it really does have the same values. So let's change the window to get really close to 2. Oop, I didn't mean that. Just window. So let's go from, I don't know, 1.5 to 2.5. And on the y value, we know the y value is 3. So let's just stay really close. Let's go from 2 to 4. Look at that. So around 2, so right there is 2, they're very similar. For the numbers bigger than 2, it actually stays very accurate for a while. So I'm going to plug in the point that I want to know. So second, calculate. I want to approximate 2.2. 2.2 is a nice, easy number to plug in. So I know you can do it by hand. So 2.2, but I'm doing the calculator because that's where I am. On the curve, on the blue curve, if you plugged in a 2.2, which you do not want to plug 2.2 in by hand to that blue curve there, you would get 3.968. If you plugged it in, so I'm going to use this up arrow to switch to the other line right there. For 2.2 for the red line, it's 3.8. So 3.8 versus 3.968. So let's do this next one. Find the linearization. Remember, that's just code for find the equation of the tangent line. We need two things to write the equation of a tangent line. We need the slope and a point. So the point, if I plug in a 3, would be 4. The square root of 4 is 2. And the slope was a little bit more work, but we did do it on the other page. So it would be 1/2 x plus 1 to the negative 1/2, which would be 1/3 square roots of x plus 1. The slope specifically at 3, oops, I know somebody already caught it probably. You don't know how to talk to me when I'm on my video. Would be 1/2 times the square root of 4. So 1/2 times 2, which is 1/4. So y, which we're going to call the linearization at x, is 1/4 x minus 3 plus 2. So this is my linearization. If I want to approximate 3.2, if you plug 3.2 in the original, f of 3.2 is the square root of 3.2 plus 1, which is the square root of 4.2, which I simply don't know. So remember, this technique was developed by people who didn't have calculators, and this was not something they could just plug in. But they said to themselves, this line right there and this curve are really close together. So here's again, we already graphed this one today. Looks like this. And this line obviously goes through that same point, 1, 2, 3, 2, and it has a slope of up 1/4. So something like that. So for a time, these two pretty much look the same. The linearization at 3.2 is going to give me 1/4 times 3.2 minus 3 plus 2. And you might be thinking, that's actually not that much easier. Well, unfortunately, it's not that much easier for you because you guys have been raised to do everything on a calculator. But back in their day, they were pretty good at this kind of mental math. 3.2 minus 3 would just be 0.2, which they know to be 2/10. So 1/4 times 2/10. These reduce. So that's 1/20 plus 2. 1/20, think about 1 nickel out of 20 nickels is 5 cents. So 2.05. What is the actual answer? If you did this on your calculator, you would get 2.04939. You got to give these guys some credit. Look at that. Our linearization produced 2.05, and the real answer is 2.04939, even though you're trying to find a point that's off by 2/10. So it is a pretty amazing feature, but this is why they call it linearization, because if you blow up any part of a curve, no matter how curvy, if you make it small enough, it actually just looks like a line. All right, last one. Find the linearization of, what is that code for? That's just equation of the tangent line. Like I said, this is not really a new topic. Ours is going to be the linearization is, so I need the slope and the point. I've already got the x value of the point, cosine of pi halves. So I'm using the y equation to find it. So f of pi halves is cosine of pi halves, which is 0. So plus 0. And I want the derivative, f prime of x is just negative sine of x. So specifically at pi halves, negative sine of pi halves is -1. So the linearization of x is negative x plus pi halves. So the linearization would be negative x, so negative 1.75 is the number that they wanted to know the answer to, plus pi halves, which if you're going to round, you're going to get a pretty decent answer. If you don't round, negative 1.75 plus actually doing pi halves, you would get that answer, which is slightly better, not that much great. But let's compare it to the actual function value. If you didn't use linearization, you actually did cosine of 1.75, you would get, look at that. Either way, even with our rounded answer to the nearest hundredth, it's definitely correct. But it's only off by 1,000th. So linearization is just fantastic. I'm going to clear my other two equations out of there and do cosine of x versus negative x plus pi halves. I'm going to hit graph. And there it is. It's, look at that, for a very long time around pi halves. So if we changed our window to just look at it from, say, 0 to pi, 3.14, I mean, you can actually type pi in there, but, and then hit graph. Look at that. Look how that linearization gives you the right answers for a long time. So anyway, it's a cool thing. And just gives us some respect for the generations that came before us. You guys might be the next generations to come up with cool things. All right, that's it for linearization. Have a great day.